All right, this is November 2nd, 2025, day 7. All right, minimum time to make rope colorful. Alice has N balloons arranged on a rope. You're given a zero index string colors where colors of I is the color of the ith balloon. She wants to make the balloon colorful. She does not want two consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You're given a zero index integer array where needed time on seconds is the time that Bob needs to remove the ith balloon from the rope. Return the minimum time Bob needs to make the rope colorful. And n can be quite large, and needed time can be an average amount. I'm thinking of DP. The whole point is to make it so no two consecutive balloons are next to each other. What can Bob do? Bob can either leave the balloon or take it, right? Well, would he ever want to leave a balloon if it would cause the rope to not be colorful? Hmm. Well, for each chunk of same colored balloons, you want to remove all except the min time one. So this can be done in O of n time by just iterating through the whole list. And while your balloon color is the same, you will just keep a track of the time that was needed in total, and also a minimum time for each balloon to be removed. And then you'll just remove all the. Oh, actually, no, you'll keep the maximum time to be removed, and you'll remove everything that's not the max. So, what would that mean? While same colors, find max, keep running sum of times, and then you're gonna add sum minus max of the total time spent. So for this one, we're going to obviously choose the 3 to remove because it takes less time. So now we just need an algorithm that would iterate through while your neighbors are the same. So I'm thinking of just iterating through one by one. Would that work? And range length of colors. And colors can only be 3, right? Oh, it could be many colors. Okay. While your colors are the same, you would want to keep track of a maximum. So how would this work? You only know that two colors are the same once you get to like the second one in a row. So you can just keep track of the current max or the current running sum. And this will be initialized to the first needed time. And then this will actually be starting at index 1 because you can't have a duplicate with only one element. At this point, what do you know? My goal is just to chunk it out, basically. I'm just trying to do this in a clean way. Hmm. Okay, maybe actually it's going to be better with a while loop. I always have a current index. So while I is less than the length of your colors, we're going to do a few things. First, we're going to try to go through this whole range with the same color. So we'll have like a current color, which makes sense. And then the current max time is going to be equals to the needed time of I, and the current total time is going to be equal to 0. So now what are we going to do? We're going to try to remove everything except for the first, or we're going to try to remove all the same colors that are in a row except for the one that's going to take the longest to remove. So while this is less than length of colors still, and current color is equal to colors of I, what are we going to do? We're going to increment this. And then we're also going to try to find a max time. So the total time that you're going through is going to be equal to the needed time of I, and the current max time is going to be the max of the current max time, and then colors of I. This will just go through the first chunk. So you would want to just increment I again at the end to start at the next chunk. Go by the current chunk of colors. So what would this do in the first problem? This should just go through the first blue. Everything is 0 right now. And then the current total time is going to be added to by 1. And the max time is going to be 1. And you're going to increment I. And this is not going to be true anymore. So what's going to happen? We're going to increment I again, which is not exactly what we want. So if this ends, it's going to be because we're out of bounds or the color changed. So actually this should not infinite loop, I believe, but it doesn't hurt to check. For Colors not defined. And the current max time, this is going to be needed time. So this should go chunk by chunk. That's great. And this I should just print out the first I. So it should print 0, 1, 2, and then 4, I believe, which is great. So there, this should print the beginning of each one. 0, 1, 2, and 3, which is awesome. And then you're going to have a result, which is going to be your current total time minus your current max time. And that we're subtracting the max time because that's the one that we choose to stay. And if it's only one element, that is just going to be 0 because you're actually not removing anything. All right, let's submit. I think that this is correct. Okay, so a little runtime and space complexity. This is gonna be O of one space because we're not storing anything that grows with the input size, and runtime is just going to be O of n. Category of this problem is not DP, then my initial assumption was wrong. The category is more so of a sliding window. But it's also not even really a sliding window because you don't have two pointers. But I would say its category is a sliding window. Okay, somehow it's dynamic programming. Okay, maybe I was right about DP. I don't know if this counts as DP though. Am I tripping? Maybe I'm tripping and I just can't figure out the DP solution, but this one works with just greedily choosing. So I missed that. It should be counted as greedy. 12 minutes solve.